Hello friends, myself Shriram Korde. We will proceed with 2D arrays now. We will understand how do you declare a 2D array and then you also give the data. That means then and there itself you are also going to define it. So that is what we will try to understand, and then we will also learn how do you provide input, and then obviously how do you show the array contents using sort of displaying that information. Okay, so that is what we will do. And then another important thing that I wanted to show you is how does typically a array 2D array looks with respect to the memory mapping. So that's a very important topic and we will be understanding it also in this video. So if I want to basically have an array, so I can just have ARR, and let's say that I will use here say 3 by 3 array. Then I can initialize it, and the way in which I can initialize it is something like this. So here you will see I have basically provided the data input, that is 1 2 3 4 whatever some data, and I have given it next to the next line. Is it required? No, it's not required. Okay, it is just to ensure that it's basically a readable. Okay, so I'm just focusing on readability, no other issue. If I would have given all the things in one line, absolutely it is perfectly okay. There is no need to really give it like this, but it makes the things easy for someone when we look at the code. That is the first point. The second point is when you are going to provide the data as part of initialization, when you declare, then columns is optional. So here let me just write it. Rows are optional. Rows are optional when during initialization, during init. So that is very important. So this is, once again let me repeat, it is rows. So this is rows and this is columns. Okay. So rows are optional if you are going to basically do the initialization. Why? Because here you have provided with 9 uh, input or 9 elements, and then if you set the column width, whatever the column width say here 3, then automatically it will consider it the rows as 3. Suppose if you have given here say 12, then here the rows will be 4. Okay, so if I give it here say 10, 11 and then 12, then the rows will be 4. That means here you either you can give 4 3, or even if you omit 4, then automatically it will decipher from the way in which you are going to do initialization. So that's a very important point I just wanted to give. Now you want to print it. So how you want to how can you do that basically? So it's very easy. For that you are going to use INJ. Some people use R and C, that means R is for rows and another is for column. So you can simply print the, so for that you can use I is equal to 0 to I less than say 4 year and then I plus plus. So this is going to be our outer loop. This is outer loop, and essentially this is about rows. That means we are talking about vertical. Okay, and I will explain you this properly. Then we will have another loop which will be j is equal to 0, j less than 3 and then j plus plus, and then essentially you just do the printing. So here you basically do the printing and then you do the tabification and then you can do the printing, and then you have another basically a printf which is outside the inner loop. This is outside the inner loop. So this is your inner loop and this is for columns. Okay, that means it is horizontal. Okay, so that's it. So how it is going to work now? So let's see this. So you have basically 4 rows and here 3 columns. Okay, so outer is basically, I told you it is for rows. So you will start with row 0, that means I is equal to 0, then j will be 0, and when j is equal to 0 it will print ARR of 0 0. Then internal loop will get completed. How? So I will still to be 0. That means 0, 0, 0, 0, 1 and 0, 2. Why? Because j is less than 3. Then it will come out, it will print the next line, which is basically it will go to the next line. Then after that I will get incremented, I will be 1. Then once again it will print 1, 0, 1, 1 and 1, 2. Then it will come out, it will go to the next line, then I will be 2, then it will print 2, 0, 2, 1, 2, 2. Then it will come out and it will print 3, 0, 3, 1 and 3, 2. So let's see this in action now. Yeah, so you can see this. This is the way in which we have printed I is equal to 0, I less than 4, and then outer rows, that is outer vertical one we have done, and I just explained to you 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, 11, 12. Okay, so that's the way typically you can do that. Now another way to provide this, suppose if I am not interested in giving this information directly, I don't want to define it there, then I can always use scanf and do it. Okay, so before that I just wanted to show you a very interesting thing, and then we will stop with this video, that is with respect to the addresses. Okay, so here let me put a breakpoint, and I am going to execute this particular code once again, and I will show it to you in the watch. Okay, so I have put a breakpoint, and I just want this particular thing to get initiated. Okay, so it has run, no issues. Now let me just do a debug. Okay, so now I have done a debug. Now I can go to watch, and here you will see you can have a watch, and you can add watch with respect to ARR. So if you just expand this, you will see there is some addresses are there. So this is row 0, this is row 1 with entries 4, 5, 6, row 2 with entries 7, 8, 9, and row 3 with entries 10, 11, 12. Okay, so here you can see this 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you expand row 0, this is the column 0 column, this is first column, this is second column, that is 0, 0, 0, 1, 0, 2. Similarly, if you expand, you will see 1, 1, 0, 1, 1, 1, 2, then 2, 0, 2, 1, 2, 2, and then 3, 0, 3, 1, and 3, 2. So that means now you can basically visualize it the way in which it can be with respect to the memory. Okay, so for that let me just I'll just copy this here. I'll just copy this value. I'll just copy this value, and let's go to the diagram that we have seen. Okay, so here obviously we can just paste it. So I just pasted it. So this is that address where whatever C60 last 3 digits. Okay, then here we can have this is the third row. Okay, so this is the way in which you can visualize it. So you can copy this another address. Let me just copy this and let me paste it. Okay, so here you can see this is that row 1 address 4, 5, 6. Okay, so here it will be 1, it will be 2, 3, and 4, 5, 6 like that. So you will see this addresses. So that means here after C60 the address is C6C. That means it is incremented by 12. Why? Because there are 3 integers, that is 1, 2, 3. 3 integers 0, 1, 2, 3 columns are there. Each basically integer here occupies, because it's a data type integer, it occupies 3 bytes. So sorry, it occupies 4 bytes. So 3 into 4, each integer occupies 4 bytes. So 4 into 3 essentially will be 12, and that's why you will see here C6C, the last one. Okay, like that you will see for the second one you can see the C78 and then C84. So that's the way. Now essentially what we are trying to learn. So what we are trying to learn is basically you will have this So let me just put it here, and now let me draw this. So this is your 0th row, this is your first row, then this is your second row, and then this is your third row. So this is your whatever the address here, this is for the 0th address here, this is what I told you, so this that particular thing, then this is that address which will be here. Similarly, whatever the address will be here, and then here whatever the address will be here. That means in the actual memory map wise, you will have like this. That is, this is 00, this is 01, 02, then here 10, 11, 12, like that. Okay, then 20, 21, 22, and then 30, 31, and 32. That's the way. That means it's essentially is a one flat array. Only thing is that here this gets demarcated like this. Okay, so that means this particular thing is 12 bytes. Why? This is 12 bytes. I just told you each integer is 4 bytes, and there are 3 columns. So 4 into 3, 12. Similarly, this is 12. Similarly, this is 12, and this is 12. So that's essentially the way in which we understand arrays and with respect to the memory mapping also. I hope you like this video. Thank you.